Hi everyone, welcome to this demo video for PathWave Test Executive for Manufacturing, PTEM. In this video, I'll walk you through how to create a test plan that controls a power supply, applies voltage to a DUT's input pins, and then routes the DUT's output pins to a digital multimeter for measurement. Let's get started. I'll begin with a new test plan. The first step is to configure the DUT. I have a single DUT in this test plan, and I'll start by adding the required pins. In this case, I'll add 4 pins, 2 for inputs and 2 for outputs. With the pins defined, the next step is to add the instruments. I'll start by adding the power supply. Set the address to the power supply, and we can click on the Refresh Module button to scan the installed modules automatically. After clicking Refresh Modules, the software scans the power supply and detects which modules are installed. For this demo, I'll use module number 2 and remove the unused modules from the list. Next, I'll add the E6198B switch load unit that contains the pin matrix card. We will use this to switch the connections between the instruments for our tests. After refreshing the modules, the system shows the instruments installed in the SLU. I'll select the 8782A and remove the rest that are not needed. Finally, I'll add a digital multimeter. For this demo, I'm using the M9183A DMM for the measurements, so let's select this. The M9183A is a PXI-based DMM. We can get its address from the Keysight Connection Expert interface easily. Just copy the resource address and paste it into the resource name entry. Now we're all set. So we've just defined all the instruments that we need in the test plan. The next step is to set up the connections between them with the DUT. This is done using Switch Manager. In Switch Manager, you can find all the instruments and DUT that we added in the bench panel. The first task here is to create a switch path. I'll start by creating a path that connects the DUT to the power supply. I'll bring in the power supply, the switch matrix, along with the DUT and digital multimeter, which will be used later. Let me just arrange them a little bit so that we can see all the connections together when we link them up. For the DUT connections, the pins are connected to rows 21 through 24. On the power supply side, the high terminal is connected to instrument 10, and the low terminal is connected to instrument 11. For the digital multimeter, the high pin is connected to instrument 1, and the low pin is connected to instrument 2. Now we can start to define the connections for the power supply to the DUT. The power supply high, which is instrument 10, will be connected to pin 3 of the DUT. And pin 3 on the DUT corresponds to row 23. So what we want to do is to connect instrument 10 and row 23 together using A-bus 3. We'll add the connection for instrument 10 to A-bus 3, followed by row 23 to A-bus 3 as well. This establishes the first connection, which is highlighted with bold lines in Switch Manager. Next, the power supply low at instrument 11 will be connected to row 24, which maps to pin 4 of the DUT. Instrument 11 and row 24 can be connected using A-bus 4. This completes the connection between the DUT and the power supply. Let's save this connection before moving on to set up the DMM. We will create the DMM switching as a separate connection from the power supply. Let's name this connection as switch DUT to DMM. The DMM high at instrument 1 needs to be switched to row 21, which corresponds to pin 1 of the DUT. So, we can connect both instrument 1 and row 21 to A bus 1. For the second connection, we will connect both instrument 2 and row 22 to A bus 2. With that, the DUT to DMM path is complete. Let's save this connection before moving on. At this point, we have two switch paths defined. One connecting the DUT to the power supply, and another connecting the DUT to the digital multimeter. Now let's return to the test plan and build the test steps. First, we'll create a test step to turn on the power supply. For this step, we will set the output voltage to 3.3 volts with a current limit of 0.5 amps. I'll set the overvoltage protection to 4.0 volts and enable the output. Now we have a power on step, we will also need a power off step as well. We can duplicate the test step and simply change the output state to off. This will give us the power off step that we need. Between these two steps, I'll add a measurement step using the digital multimeter. This will be a simple DC voltage measurement. I'll set the accuracy speed to 0 for the fastest measurement and expect a measured value of 3.3 volts. After turning on the power supply, it's usually a good idea to allow some time for the voltage to stabilize. Let's add a short delay of 0.5 seconds before taking the measurement. At this point, the measurement steps are in place, but we're still missing the switching step. We need a step that activates the switch paths connecting the DUT to the power supply and the digital multimeter. To do this, I'll add a switch step and move power and measurement steps under it as its child steps. In this way, the power on, delay, measurement and power off steps will run within this switch step. This simplifies the test plan structure and keep the test steps well organized. This switch step activates the predefined connections. Under the connection settings, I'll select both switch paths. One for connecting the DUT to the power supply, and another for connecting the DUT to the digital multimeter. At the setup of the switch step, we will set it to connect the paths, and at the end of the step execution, we will disconnect the paths. Let me move everything into the main test group of the test plan, and we are ready to run our test. First, click on the Connect button to get the instruments connected and initialized. Wait for the connection button to turn blue, and the instruments are ready to go. Now let's run the test plan. The measurement result shows 3.3 volts. This is exactly the same as the output that we set up in the power on test step. If I change the switch step to disconnect the path and run the test again, no voltage is measured because the connection is no longer made. Switching it back to connecting the path restores the 3.3 volt reading. Next, let's add a test limit to validate the measurement. I'll name the limit test output and use a nominal tolerance limit type. Set the expected nominal value to 3.3 volts and a high and low tolerance of 0.05 volts. This will provide a clear pass or fail result. Running the test again shows the measured value falling within the defined limits. At this point, no DUT result is shown because the result hasn't been assigned to a specific DUT. Since there is only one DUT, I'll assign the result to DUT 001 and run the test again. Now the DUT result clearly shows a pass or fail status. We've come to the end of this demo. We've created a test plan that connects the power supply, DUT, and DMM together and executing a power-up voltage measurement test, all in just a few minutes. So check out Keysight Hands-On channel in YouTube for more useful tips and features of PTEM and get on your way to creating simple and efficient test plans. Thanks for watching and have fun. Bye.